Okay, so and another important issue, and you're going to see how this distribute, is that, you know, it's a big region. We cannot do that by ourselves only, and then we try to get as much as we could of partners that had field plots. So as you know, field data is not trivial to get, and in the Amazon it's not trivial to get twice. And, but we had a strong team of collaboration. You're going to see a little bit more where this distribute. And the idea is to feedback. So how we could first fly over a site that was being already monitored. And second, how we could fly over a site that could be monitored in the future with some specific field data. So we tried to feedback this as much as we could. So this is how this distributes the field size that we use, part of that for calibration and part of that for validation of the LiDAR samples. So they distribute based in and then if you remember Graciela slides on the very first beginning, those are the sites that are represented that as well. And those are the group that we did. So, well, so that's basic how the whole flow of the project happened. So from the ground data to the LiDAR, and then how we define the above ground biomass using Marcus Longo's model, and then how we interpolate through the whole region use remote sensing data. Then we use this, the random forest to actually calculate also regression and a mean error for this. And then we had the map. The model actually was used, this model was actually used, we used approximately 150,000 cells of 250 meter of spatial resolution. And then we actually feed that to have the interpolation, the modeling to calculate also the uncertainty. So this is the model. Probably most of you know of it. And so that was I'm not going to spend time on this. It's just that was published by Marcus and Michael and the group. So that was used, that was very well calibrated. So that was already calibrated by Michael's group. Then we use that as well. We test in several sites, and it worked very well. But sure, there will have challenges associated to this. First is that the plot size, the field size, we could not use all of 400 sites we had. We cannot use all of them because the different on plot size, different on how the forest inventory was conducted, different years between the data, so there's all issues that we deal with. Well, in terms of LiDAR, we had a huge data set. You know, we had a 15 gigabyte transect plus, leading to 15 terabyte of total. So, and then we had challenge in terms of processing and thus far. But that's part of the game. The whole geodatabase, so the idea is to have this available. So to this point, several partners have already access to the data and are producing information. But the idea is having this open to the community so community can use as much as needed. And Mauro, who is here and tomorrow has a poster, and he's the guy responsible for the geodatabase, and he's the guy that can talk much more about this than I. So this kind of fell from from the slides a little bit, but this is the new map that we produce out of this data. This is a map of the median actually height of the forest. And this is the uncertainty map. So the uncertainty map, we basically ran 1,000 samples out of the validated sites that we had. then we produce 1,000 different maps, and then we use that to calculate the uncertainty. So the standard deviation of that gave us the uncertainty from the field plot to the Marcus Longo equation to the random forest to interpolate this. So we were able to produce the uncertainty map and produce a new biomass map. And then we also look into the structure of the forest in a way, not perfectly, but in a way, look into that in terms of mean height of the system. So how this come back to the reducing the uncertainty for a national communication, for instance. So we have, here is the whole diversity of, vegetation types that there is in the region. And this is the base for the previous map, which was this one here. And then we're comparing those maps. So our map is a little bit higher in biomass in some place, as we expected, and lower in other place. The major part of this falls into a not very different biomass per hectare, but it can get up to, I don't know, some regions, 70 or 80 tons per hectare of the new map compared to the other one. So this is actually something that could eventually support the forest reference level that Brazil has, and also the communication to the climate convention. Okay, so in terms of other outcomes, what else? So as you specialists on this, so how we can definitely extract a lot of information of this data set. So one very cool one that came out very recent was coordinated by Eric, and well, he found a tree which is almost 90 meters tall in the Amazon. And a very cool thing is that in a parallel analysis of this, Sassan's group found the same tree, so which for us is very good in terms of consistent of the sampling that we produce. So it's a very cool thing. It came out in a very important moment in terms of evaluating the Amazon as a whole ecosystem, and certainly Eric can talk a lot about the field trip and the mission they had over there to find that tree. So also the forest height, the median forest height, we're looking to this as a potential look into the structure of the region, which can be very useful for carbon studies in terms of carbon flow and ecosystems and ecosystem dynamic, species distributions, and thus far. Another group that we interact quite often is with Aragão's group, and they're looking here to the fragmentation, actually, of carbon loss due to fragmentation in the forest, and how this fragmentation actually propagate from the borders of a specific fragment in the region, and how it's important. Sorry, this really mixed up a little bit, but how this is important in terms of carbon emissions. So all these little brown boxes are associated to the emissions related to fragmentation in the forest. So LiDAR is a great tool for that, because you can propagate how the structure of the forest maintained after a disturbance. Other very cool things that are coming out, so we're finding, so Acre is a region that's very famous to have geoglyphs. So there's several publications that, pointing this out already. But we did find some geoglyphs there on the upper part of the Amazon, which is the border to the Guianas up there, and where the big tree was sitting. And we found some geoglyphs in that region as well. So it's incredible too, it's incredible data set that can be explored several ways. So this is the, so those are the partners that were listed up there briefly, but here in a more, let's say, a comprehensive way. We provide data for, at least we provide data for Jedi, for instance, to also to look to help on the calibration, and so we did a lot of. So it's a growing list of collaboration. This was funded by the Amazon Fund, which is a fund from the Brazilian government sitting on this bank. So when I start saying that the motivation to get the fund has to get the heart of the funder, that will happen, and then we were able to get this from a bank, which anyway. And and then we had also a sponsor from the USAID on the peer funding scheme that they have. So that's a project that I have with Michael and Sasan. So that was part of the funding for this as well. And obviously this cannot be done. So as I mentioned, I was captured by this LiDAR universe, but I'm still the guy sitting there thinking about in a more of a drawing way of being. But you know, the people that really did a lot of this work and put this together and get all this data and interact are all this team here. And a very cool thing is that maybe besides Mauro and myself, most of the people are very young researchers, and we are young in heart, right, Norma? And but you know, it's a very, very enthusiastic team of people working on this. Okay, so as a closing remarks on this talk, I think the data definitely support a comprehensive view of the Amazon forest biomass. It really did help a lot. It helped to bring this context of the several information we had into a comprehensive reading of that forest, which include the way we did, but with the information we had, which include uncertainty, very important, as Vena just mentioned to us, and the structure of the forest, which I think it has a huge opportunity to follow up in terms of science. The interesting part is also it led to a box on the IPCC guidelines, the refined guidelines, as a potential way of measuring native forest biomass. So that will come out, which was really, really nice. And I think it's still, the data is still very new and very alive to allow the community to have and to look to new things and to look to new interests in the Amazon region. So the data is basic, associated to this project. It's based a full waveform from all LiDAR clouds. We have it. We also have the discrete data from all the clouds, the normalized points, the metric calculating clouds at this resolution of 50 by 50, and all the satellite data that we use actually to interpolate through random forest, which we use MODIS, we use SAR, and to do the interpolation is also available, will be available with the data. And I think with that, yes, I'm done. Yeah, a little bit before time. Is that okay? All right. Thank you very much for your attention.